Hello, good day, viewers. In this virtual class, we're going to be looking at these questions. Now, when you have a limit as x tends to 0, sine x or x equals to 1. So we're going to show why is it so by using the power series. Okay, using the power series. Now, the power series here, if we have a f of x here is given as a naught plus a1 x over 1 factorial plus a2 over s squared over 2 factorial plus a3 s cube over 3 factorial plus or continuously like that. Now, what it says here is that the function we're looking for here, if f of x is sine x, now we could simply say that, at this point in time, we're looking at this when we have a x is equals to 0. So imagine if we have a f of 0 here, or this function here, we have f of 0 here. What will be left here is just a naught. Okay, now let's look at this. If we have a f of 0, we put sine 0 here is what? Is 0. So at this point here, this place is 0. Okay, so here is 0. Now let's look at this. If we find f prime of x, so that means we differentiate sine. This is what is going to give us. A cos what x. So let's find f prime of 0. Cos 0 is 1. Of 0 is 1. So if we take the second derivative, f prime of x, to differentiate this, this will give us negative sine what? Sine x. Then if we look for f prime of 0, it's going to give you 0. So let's try this. F prime of x. So if we differentiate this, it's going to give us what? Negative what? Negative cos x. So f prime, okay, of 0, this gives us what? Negative 1. So we see that it is only the odd that is existing. All the even function here, they are always off. So if we now look at this, so what we have here, the f of x. So for sine x, the function for sine x here definitely is, at this point here, when we put this thing here, when we put f of 0 here, okay, this place is 0 here, so this place will be 0. But when we put it here, when we differentiate the first one here, it gave us what? 1. So we use this one here to multiply this. So this will just give x. So the next one, if we differentiate this series here, the way we are differentiating this, we differentiate this one. What we're going to have here is just going to be a2, and your a2 here is dead. So the next one is this. If you differentiate this one will be what? Minus s cube over 3 factorial. The next one will be loss what? X raised to power 5 by what? 5 factorial. That's how it will do here. So it is only the odd term that exists. Okay, the next one will be negative. Now, this is for sine x. I hope we can see that. So what we need to do here, we are saying sine x divided by x. It means that here, sine x over what? X means when I come here, I will say one of the functions is x over x minus s what? Cube over 3 factorial what? X plus s raised to power 5 over what? 5 factorial divided by what? X. Now, what we divide is, what will be left here is just 1. This will be s squared over what? 3 factorial plus what? X raised to power 4 over what? 5 factorial So that side will continue here. We now discover that if we are now saying as x tend to 0, see, every other thing here will be off, and what will be left here will just here goes to 1. So that is why when anytime you have a limit as x tends to 0 of sine x by x here is equal to 1. So these are the simple proof to it. Okay, it's obtained from the power series or using the Taylor or Maclaurin's series approach. Please, if you find this video useful, please let me subscribe, share, like. If you also need me one-on-one coaching, please do not hesitate. You can DM me. See you in my next virtual class.